Hello and welcome to my channel MathSab. So today in this video series I will be talking about change of variables, that is how to change from Cartesian coordinates to polar coordinates in multiple integrals. So let's move on. So we have three types of conversions when we convert Cartesian coordinates to polar coordinates, then when we convert Cartesian coordinates to cylindrical coordinates, and the third one when we convert Cartesian coordinates to spherical polar coordinates. So we will learn all these change of variables in three different videos. So to begin with, we will start with changing Cartesian coordinate system to polar coordinates and vice versa. So let us try this question. So whenever we have an integral in polar coordinates, the integral limits are always in r and theta. And when we try to convert this into Cartesian system, then we have to convert it into dx, dy, right? So let us try to see this question. Transform the integral to Cartesian form and hence evaluate integral 0 to pi integral 0 to a r cube sine theta cos theta dr d theta. So whenever we are converting Cartesian to Cartesian to polar or polar to Cartesian coordinates, then the transformation is always x equal to r cos theta and y is equal to r sin theta, right? So now in this, so this is what happens when we have an integral in, suppose the integrand is f of x comma y and we have dx dy. So how does this change? This will change as f x becomes r cos theta and y becomes r sin theta. So now what happens to this dx and dy? This dx and dy will get changed to Jacobian dr d theta. Now what is Jacobian? J stands for Jacobian. It means it is the value of the change in this coordinate system. So the earlier coordinate system is in x and y, and now the new system is in r and theta. So Jacobian is the determinant of this matrix. We will start from the first variable x, del x by the new coordinate system, that is del r, del x by del theta. Similarly, now we will start with y. So we will have del y by del r, del y by del theta. So now let us place the values of del x, del r, del x by del r, del x by del theta, del y by del r and del y by del theta. Now when x is r cos theta, so del x by del r will be cos theta and del x by del theta will be minus r sin theta. Similarly, del y by del r will be sin theta and del y by del theta will be r cos theta. And now when you take the determinant of this matrix, you will get r cos square theta plus r sin square theta, which is equal to r. So that means whenever we are converting a Cartesian system dx dy to polar system, it will always get converted as this Jacobian will become r. So it is r dr d theta, right? So with the help of this transformation, let us try to convert this integral to now Cartesian form and then we need to evaluate it. Now, so let me just clear this section. Okay. So now we have the integral 0 to pi, integral 0 to a, r cube, sine theta, cos theta, and then we have dr dt. So let us try to write it in a proper way. So we will try to write it as 0 to pi. I'll split r cube as r sine theta. Then I'll split one r with cos theta and let me split one r with dr d theta, right? So now when I convert this into Cartesian system, I'll have the limits of x and y. So we know that r sine theta and r cos theta, this is x and y, and r dr d theta can be replaced as dy dx or dx dy according to whatever order you fix. And whatever order you fix here, you have to put in the limits in the similar way, right? Now let us try to plot this region. If you check the limits of the given integral, the limits of r is ranging from 0 to a, right? So we have a circle with radius a, and the limits of theta is ranging from 0 to pi. So these are the limits of r and theta, right? So if I plot this, this is the circle with radius a, and theta, the limits are from 0 to pi. So it is just this orange shaded portion, right? We are not considering the entire circle because theta is not ranging from 0 to 2 pi, but it is ranging from 0 to pi. So once the range of r and theta are fixed, now let us try to convert this into Cartesian system. So according to the Cartesian system, if r is equal to a, that means x square plus y square under the root will be equal to a. So this will be x square plus y square equal to a square. So since I've written dy, so I'll take up the strip. So I'll take a strip in this region, a vertical strip, since I've written dy here. Now, where is this strip entering the surface? It is entering at y equal to 0. And where is it exiting the surface? It is exiting at the equation of the circle. So from here, if I calculate the value of y, I get a square minus x square, right? And now to check out the limits of x, the minimum is minus a and the maximum is plus a. So we will have the limits from minus a to plus a, right? Now when I integrate this, I'll get minus a to a. Integration x will be kept constant. Integration of y will be y square by 2. And we put the limits as 0 to under root a square minus x square dx. So that will become, I can take out 1 by 2 common. Minus a to a, x is already there. Y square will be replaced with a square minus x square dx. And now when I integrate this, we get half. A square x will get integrated as a square x by 2 minus x cube will get integrated as x4 by 4. And when I put the limits minus a to a, they are both even functions. So the integrand answer will become equal to 0, right? So I hope you understood this transformation, how we converted the polar system to Cartesian system and evaluated it, right? So let us try another question. So we have to evaluate integration 0 to 2, integration 0 to under root 2x minus x square plus y square dy dx. So now let us try to convert the integrand first. X square plus y square will become r square. Now what is dy dx? It is the Jacobian, that is r dr d theta, right? Now let us try to find out the limits of the integral. So from the given question, the limits of y are fixed as 0 to under root 2x minus x square. And the limits of x are fixed as 0 to 2. So let us try to figure out what type of curves are this. So we try to forget all the inequalities first and let us try to take the equalities. So y is in under root 2x minus x square. So let us square it up. So we will get the equation as x square plus y square minus 2x is equal to 0. So let me complete the squares of x. So I will get x square minus 2x plus 1 plus y square is equal to 1. So that becomes x minus 1 whole square plus y square is equal to 1. So what type of curve is it? It is a circle whose center is at 1, 0 and the radius is equal to 1. So this is one curve. Then we have y equal to 0, we have x equal to 2 and we have x equal to 0. So when we plot this, we get a region of this type, circle whose center is at 1, 0, radius is 1, x is equal to 2 is this line, x equal to 0 is the y-axis and y equal to 0 is this axis, right? So you can say it's a semicircular region, right? Now, From this semicircular region, let us try to find out the limits of r and theta. So let us try to figure out what is the equation of this curve in polar coordinates. So since I get x square plus y square minus 2x was equal to 0, so I can write this as x square plus y square is equal to 2x. So if I convert this into polar system, this is r square and 2x will become 2r cos theta. So if I bring both the equations on one side, I'll get this. So r is equal to 0 and r is equal to 2 cos theta. So from here, I get the limits of r as 0 to 2 cos theta, right? And similarly, theta is ranging from 0 to, it's in the first quadrant, so theta ranges from 0 to pi. Okay. So now let us try to evaluate this integral. We have r square here, so we will get 0 to pi by 2. R cube integration is r4 by 4, limits from 0 to 2 cos theta. Integration with respect to theta. So I can take out 1 by 4 common. I get 0 to pi by 2. R to the power 4 will be 2 to the power 4 cos theta. So it is 16 cos to the power 4 theta d theta. So 16 and 4 cancels and we have 0 to pi by 2 cos 4 theta d theta. Now, in my very first lecture of multiple integrals, I've talked about the reduction formulas. So I can start with the reduction formula in the numerator. I'll subtract all the odd powers. So 4 minus 1 is 3, then 1, and then it will become negative. So I'll stop here. And in the denominator, I'll start with 4 and I'll subtract all the even powers. So it is 4 into 2. And since the power is even, I'll multiply it with pi by 2. So 4 cancels and we get the answer as 3 pi by, right? So I hope you understood this question, how we converted this variables, the Cartesian system to polar system, right? Now, let us move to one more question. We need to evaluate I equal to 0 to infinity, integration 0 to infinity, e to the power minus x square plus y square dx dy. So how to integrate this? Now, from here, the given limits of x is from 0 to infinity and the given limits of y are also from 0 to infinity. So let us try to convert this. So e to the power minus x square plus y square can be comfortably written as e to the power minus r square and dx dy can be written as Jacobian, which is r dr d theta. So now from here, I need to calculate the limits of r and theta. So if I try to plot this region, this is my x, this is my y, and I can see that x equal to 0 is y-axis, x equal to infinity is somewhere unbounded on the x-axis, right? Similarly, y equal to 0 and y equal to infinity. So it is an unbounded region, right? Now, if this is an unbounded region, so how will I get the limits of r? So you can see that this is my entire region, right? So now if I take a strip in this, for r I have to take a strip. So r will enter at 0 and where will it exit? Since x and y are unbounded, so r will automatically become unbounded, right? So r will equal to infinity. And since the region is contained in the first coordinate plane, so the limits of theta will be from 0 to pi. Now let us try to figure it out how to solve it. Let us put r square equal to t. So 2r dr will be equal to, so the integration becomes 0 to pi by 2 integration e to the power minus t r dr will become dt by 2. So let me keep this 1 by 2 outside and d theta. When r is 0, t is 0. When r is infinity, t is also infinity. So this is half 0 to pi by 2 integration of e to the power minus t is e to the power t by minus 1 limits from 0 to infinity, and then we will integrate it with respect to theta. So this is half 0 to pi by 2. Now e to the power minus infinity will become 0 and e to the power 0 will become 1. So 0 minus 1 is minus 1. So minus 1 and minus 1 cancels and we simply get d theta. From here, this is half theta 0 to pi by 2. So that becomes simply pi by 4. Right? Now from this integral, very important result will be derived. Now if you have checked my previous videos on change of order of integration, there I have left one integral as e to the power minus x square dx, right? So you can see it's a definite integral from limits from 0 to infinity. So x square doesn't matter, so it's a dummy variable. So let me write I as 0 to infinity e to the power minus y square dy. So when I multiply them, I get I square is, I'll get a double integral from 0 to infinity. Exponential terms will get added. We will have x square plus y square, and then we have dx dy. So I've just calculated this integral and the integral value is pi by 4. So the value of I becomes under root pi by 2. So whenever you get these type of integrals, we got there, and I told you that I will be solving it in my further videos. So this is how we get the value of root pi by 2, right? So I hope you understood this question. And now you need to practice these questions, right? So try them. And I've given you the answers also. So do let me know if there is any doubt in these questions. Comment it in the comment section. And if you like my video, do hit the like button. And if you haven't subscribed my channel till now, do subscribe it. And have a nice day. And always believe in yourself. You can definitely do it. Thank you so much.